Okay, welcome back. Good morning to all. So these are the advantages and disadvantages of symmetric algorithm. In the advantages of symmetric algorithms are that efficient, they take less time to encrypt and decrypt the message because there is single key is exchange here. Next is your disadvantage. In symmetric cryptography, each pair of users require unique secret key. If n number of people in the world wants to use this technique, then there needs to be n into n minus 1 by 2 secret keys. For 1 million people to communicate, a half billion secret keys will be needed. Sharing the secret key between the sender and the receiver is an important issue. While sharing the key, attackers might intervene. So these are the advantage and the disadvantage. Next can come to the overview of asymmetric cryptography. In asymmetric cryptography, each user has two keys, a public key and a private key. Both keys are mathematically related. Both keys together are called the key pair. The public key is made available to anyone. The private key is kept secret. Both keys are required to perform an operation. For example, data encrypted with the private key is unencrypted with the public key. Data encrypted with the public key is unencrypted with the private key. Encrypting data with the private key creates a digital signature, and this ensures that message has come from the stated sender. A digital envelope is signing a message with a recipient's public key, and a digital envelope which serves as means of access control by ensuring that only the intended recipient can open the message. If the private key is ever discovered, a new key pair must be generated. So in case of the asymmetric key cryptography, the two different keys are used. One is your public, another one is the private key. So in the asymmetric cryptography, the one important algorithm is known as the RSA algorithm. So come to this RSA algorithm. The RSA algorithm is most popular and proven asymmetric key cryptography algorithm. Before discuss that, we move to the algorithm part. The RSA algorithm is based on the mathematical fact that it is easy to find and multiply large prime numbers together, but it is extremely difficult to factor their product. So the private and public key in the RSA are based on very large, that means made up to 100 or more digits prime numbers. The algorithm itself is quite simple. However, the real challenge in the case of RSA is the selection and generation of the public and the private keys. Now let's discuss about this RSA algorithm. First, step 1, generate the RSA modules. The initial procedure begins with the selection of two prime numbers, namely P and Q, and then calculating their product n. As shown, n equal to P into Q. Here let n be the specified large number. Step 2 is a derived number. Consider number E as a derived number which should be greater than 1 and less than P minus 1 and Q minus 1. The primary condition will be that there should be no common factor of P minus 1 and Q minus 1 except 1. Step 3 is your public key. The specified pair of numbers n and e forms the RSA public key and it is made public. Step 4, private key. Private key D is calculated from the numbers P, Q and E. The mathematical relationship between the numbers is as follows. The mode P minus 1, Q minus 1 equal to 1. The above formula is the basic formula for extended Euclidean algorithm which takes P and Q as the input parameters. This is the encryption formula of the RSA algorithm. Consider a sender who sends the plaintext message to someone whose public is N and E. To encrypt the plaintext message in the given scenario, use the following syntax. City equal to P T to the E mod N, and decryption formula. The decryption process is very straightforward and includes analytics for calculation in a systematic approach. Considering receiver C has the private key D and the result modulus will be calculated as Pt equal to Ct to the D mod N. That is the decryption formula. So in the RSA algorithm, suppose there is a, you can say, let's take an example here. Let P is the, what is the P? P is the 47 and Q is the 17 as the last prime numbers P and Q. So first calculate N equal to P into Q, that means 7 into 7, that means P into 7. Then you have to find out the P minus 1 and the Q minus 1. Then step 3, then step 4 is the private key, and this is the RSA algorithm. Next come to the digital signature. A digital signature is a technique that binds a person or entity to the digital data, and this binding can be independently verified by receiver as well as any third party. So digital signature is a cryptographic value that is calculated from the data and a secret key known only by the signer or signature. So mode of digital signature here. Here the signature and the verifier, the data. Then you have to apply the hash function, then hash, then the signature algorithm, signature private key is added here, then move data and signature, data is the hashing function equal, signature verification algorithm, hash and the equal, signatures public key. So this is the model of the digital signature. So next is your importance of digital signature, message authentication. When the verifier validates the digital signature using public key of a sender, he is assured that signature has been created only by sender, who possesses the corresponding secret private key, and no one else. Data integrity: in case an attacker has access to the data and modifies it, the digital signature verification at receiver end fails. So the hash of modified data and the output provided by the verification algorithm will not match. Hence, receiver can safely deny the message assuming that data integrity has been breached. Non-repudiation: since it is assumed that only the signature has the knowledge of the signature key. He can only create unique signature on a given data. The receiver can present data and the digital signature to a third party as evidence if any dispute arises in the future. Next is your encryption with digital signature. This one is the last one of this chapter. This can achieve by combining digital signature with encryption scheme. And let us briefly discuss how to achieve this requirement. There are two possibilities, signature then encrypt and encrypt then signature. First is your sender side data encryption using receiver's public key. Hashing function then hash digital signature with sender's private key, encrypted data plus digital signature. So this is about chapter number 3. Next class we are going to discuss about chapter number 4. So thank you to all.